I'd like to do an example of maximizing a quadratic function. And here we're going to look at maximizing the height of an object that's thrown upwards. So we have a rock that's thrown upward with a velocity of 80 feet per second from the top of a 64-foot tall cliff. What is the maximum height of the rock? We can determine the maximum height of the rock from the equation that governs vertical motion. So let's write that down. So we have that h of t, so the height at a particular time of the object thrown upwards, is negative 1/2 g t squared plus v naught t plus h naught. Now here, the g is the acceleration due to gravity, t is time, v naught is the initial velocity in the upwards direction, and h naught is the initial height of the object. Now we can fill out this equation for this particular problem. First off, we're in feet, and the gravity for feet is 32 feet per second squared. So let's put that in. So negative 1/2 32 t squared. V naught is the initial vertical velocity. That is 80 feet per second. So we'll have 80 t. And then h naught is the initial height. So the object is 64 feet in the air to begin with. All right, now this gives us negative 16 t squared plus 80t plus 64. All right, so this gives us the height of the object at time t. Now we can maximize this by finding the vertex. Recall that we know that the vertex of this is either the maximum or minimum depending on the a, and the a is the coefficient of the quadratic term. That's the term with the variable squared. This is that term, with t squared, and its coefficient is negative 16. That means if we were to graph this, we would get a parabola that opens down. The vertex would be the maximum. So if we find the vertex for this, we're going to find the maximum height. So we can use the vertex formula. Recall that's negative b over 2a. That will give us the time value before this rock reaches its maximum height. Then we can take that time value and plug it back in here and get the height. All right, so let's write that down. Negative b over 2a. So here we have negative b, so b is the linear coefficient of the linear term. So negative 80 over 2a. 2 times negative 16. All right, so we have a negative over a negative, 80 over 32, and we can simplify that. So it looks like there's an 8 in both. So we have 10 over 4, 5 halves. So 2.5 seconds before the rock reaches its maximum height. Now we can take this and plug it into our height function and get the maximum height for this rock. So we have h of t, so h of 5 halves is going to be, let's take this form, so negative 16 times 5 halves squared plus 80 times 5 halves plus 64. Okay, so let's see, we have 5 halves squared, so negative 16 times 25 over 4 plus, and here we have 5 halves times 80. We can take the 80 and divide by 2 and get 40 times 5 is 200 plus 64. Here we have 16, negative 16, divided by 4, which is negative 4, and negative 4 times 25 is negative 100. So we have negative 100 plus 200 plus 64, and that's going to be 100 plus 64, 164 feet. So the maximum height of this rock is 164 feet after 2.5 seconds.